Yeah, the electronics and clothing, and then for each one of the product types, you have to put the product price and then the age requirement, right? And then to get a discount. So greater than or equal to $500 and the age less than 18 years is a 10% discount. Greater than 500 and greater than 18 years is 20%. And you fill out the table for all the possible scenarios given, the description here. Okay, so there's another example here based on transportation, right? So a transportation company provides services for customers and charges based on distance and number of passengers, right? So the pricing depends on the type of transportation, which could be either taxi or bus. So you have taxis, and if the taxi has one or two passengers, it charges 5, 10, and $20 for a distance of 0 to 5, 5 to 10, and 10 plus kilometers. The taxi with 3 or 4 passengers charge 10, 20, and $40 for a distance of 0 to 5, 5 to 10, and 10 plus kilometers respectively. And then finally, the bus has its own set of criteria. So the bus has much more passengers, up to 30, and charges $50, $100, and $200 for a distance 0 to 10, 10 to 50, and 50 plus kilometers respectively. So for this one, you all could have a look at it and then try the table for that, right? Okay. The next testing is that of state transition testing, and this would be applicable to many projects solutions you'll come across, right? So you have a state transition testing. This is a black box testing technique and is used to test the functionality of the system or software that allows a transition from one state to another. So many solutions would have this being applicable, as I said, like ATMs and login for web pages and things like that. Okay, so what you're going to do is you will analyze the behavior of the system and how the state transitions from one state to another, depending on what is input into the system. Okay, so right, so it's pretty good for a system that has multiple states. And then in order to put this in place, you have to identify all the possible states and then the transitions that can happen. Okay, so to do this, there's a step by step, identify all the states of the system and then identify events that cause the transition from one state to another, right? Then, you create a transition diagram and then you design test cases to go through that. And remember, for those of you who were in software architecture last last semester, we did some UML diagrams that captured states or similar sort of solution, right? So you see that would have been done in the design phase, and now in the testing phase of your project, there is a testing technique that you could apply to that sort of solution. All right, so yeah, it's good for sequential logic solutions. ATMs, shopping carts, games, etc. Right? But for systems that do not have clear states, it's not really applicable. So it all depends on your solution and what testing technique is best for it. Right? So similar to when we did the design with UML diagrams, you don't have to do a UML diagram for every possible scenario in your solution, but there are some scenarios that the UML diagram is more applicable, right? So we have a traffic light system. So suppose you're testing a traffic light system, and when the lights turn from red to green to yellow and then back to red based on a timer, right? And this is an example of what your transitions table would look like. So you have the current state being red. When the timer expires, it goes to green. If the state is green and the timer expires, it goes to yellow. And if it's yellow and the timer expires, it goes to red. right? And I think last semester, oh, we have the group. Yeah, last semester we did embedded systems. A group of students did a traffic light system. So if you were to expand on the project, you would do this sort of state transition testing to test your project and then document it there, right? So quickly, this is how it would look. This is a very simple one, right? But it would have other events also because I think I think you all put in like buttons if persons wanted to cross, right?
Yes, sir.
Yeah, yeah, buttons and stuff. So, right. So you will have, if you had to do it for your project, you'd have had like other events causing the state to transition from one to another. So it's exploring all those possibilities. Okay, so that's that. Okay, this other example is with a shopping cart. So suppose you're testing an online shopping cart with the option to add or remove items from your cart, right? You could also check out, complete your order, or you could cancel everything. Right? So, for example, you could use a shopping cart, and then you have some test cases, right? Um, and you could use these states to test it. So you can have an empty cart, cart with one item, cart with two items, three items. You can check out the cart. You could have an error, and you could also have a thank you, right? So this will also lead into a you could also use a state transition diagram for it. One second, I'm not sure why this isn't showing. Okay, now it is. Yeah. So this is the state transition diagram table for that scenario. So you see um it's much bigger, right? It has the current state and then all the possible events, or at least the ones we looked at to move to another state. So if you have an empty cart, you could add an item. You could try removing an item, but if you remove an item, it's an error, obviously, because you have nothing in the cart to begin with, right? You add an item, it goes to a one item state. If you look at that state, you add another item, remove an item, it changes to the applicable states, right? And you can go through the rest of the table there. Ideally, your state transition table should cover all the possible scenarios or most as much scenarios as you can to fully test the system. All right, so the diagram will be a little more complex, than the previous example, the traffic lights. Right, so you have your states here, and then how you move from one state to another, and the action that is required. Okay, the next thing we're going to look at is use case testing. And use case testing is the software testing technique that evaluates the software's ability to meet the end user's requirements. Okay, so in this case, you're testing a particular scenario. Okay. Um, so it involves creating test cases based on specific scenarios and then testing the scenarios itself. And there are specific requirements for that. So some benefits is you have an improved software quality, better test coverage, and it's easier to understand because persons would understand the scenario a little better. So if it is, we were looking at maybe registering on an application or registering for a user um, an account. You could register for an account, log into the account. You could perform different actions on the web page, etc. Right? So it tests the entire scenario. So it helps with the business logic also. But in order to do this, you have to ensure that the scenarios are well defined. So it's like an end-to-end sort of scenario definition. And with that could be time consuming. Okay, so you have to be careful with the advantages and disadvantages. So, for example, with a banking app, you can test scenarios for user authentication, um, account balance update, and then the user receives the cash, right? So th this is the use case would include all um, these test cases, right? So if you go with your ATM card or your banking card to the ATM, you would have to first authenticate you as the user. Um, then when you select the operation, your account balance will be updated. And then finally, you would receive the cash. The other testing we'll look at is pairwise testing. And with pairwise, what happens is you use a combination of input parameters to be tested at once, right? So instead of testing one parameter by itself, you actually use two parameters together. And with this, it covers the possible combination of the inputs, right? And it also provides high-level test coverage. Okay, right. So yeah, it greatly reduces the number of test cases. And it is useful when you have multiple input fields. Right. Okay. Okay, so for example, let's say we have a web form and that web form is accepting first name, last name, email address, phone number, and country. So instead of testing each one individually, what you will do is you will create a list of all the possible values for each parameter. So let's just say um, you have persons registering on this web form. So you create some test values. Then what you're going to do is you will group parameters into pairs and generate some options, right? So you want to test first name and last name, then first name and email, first name and phone number, etc., right? So you're basically going to group all the different fields into pairs and test the form. So that's good for saving some time. Okay. And then you put the values of the pairs in for testing. I could also do some sort of different set of data, right? So if you use first name and last name, you could have valid first name and last names, right? Then you could enter the amount of characters allowed. You could actually leave one of the fields blank, enter invalid values, or you could enter some non-ASCII characters, right? Depending on the language. Okay, and what you do is you will repeat this for each pair. So basically, you're going to take a pair, you're going to go through some different combinations, and you repeat it for each pair. And that way, it gives you some good coverage in general. Okay. Right. Okay. The next one, so after pairwise testing, we have error guessing. And error guessing is a software technique that is based on a tester's experience, intuition, and creativity to identify potential defects in the software. Okay, so this is if you are like you have built multiple similar applications. You could use your experience to test some data and see if the solution passes that, right? Okay, so it's normally a quick sort of test, but it's not really too formal, so there's no real documentation, right? It depends on the tester's knowledge and domain. So it's kind of like, you are in the workplace and you're maybe a junior developer and you're developing an application, and as you develop the application, you might talk to someone senior in the team, and then they may say, well, did you test this? Did you test that? Things like that. So they're going to use their experience to give you some testing feedback here, but they're not really going to document all that. You're going to have to test that yourself afterwards. Okay, so like in a registration form, right? You might want to just put some special characters. You might want to leave the field blank, put an email address in the wrong format. if you have to enter a password and confirm the password, you might put some mismatched passwords, some quick stuff. All right. So let's just say we're testing an e-commerce website that has a checkout process with multiple pages. And what an experienced tester might do, instead of going through a full suite of tests, right? So they might just test some stuff that usually gives problems, right, in implementing. So they might submit an order with an invalid credit card, or might put in a shipping address or a long address field. So some things that they have experienced in the past, they'll just quickly test those scenarios. So you really don't want to use that by itself, right? It's just more like a litmus test. Okay, exploratory testing. And this testing is a software technique that emphasizes on freedom and creativity of the testers in the testing process. Okay, so it's where the tester just learns about the software while using it. So um, you're calling someone to ask them to test a new application. So they don't really know what the application, how it works. They just install the app, or you just present them the application, and they will just navigate different options and let you know how, give you some feedback. Okay, so when you test like that, it really simulates some real user behavior, because if you're selling an application or solution to customers, they would not have in-depth knowledge about it, and they will sort of learn as they go. So they might even, may not even read a manual or advertisement or anything. They just have an application, just use it. Okay, but again, this is less structured, right? And you can't really measure coverage because you don't know how many scenarios, how many use cases you're testing, etc. Right? So these testing is not really to replace the other more systematic techniques we looked at, but is to complement it in a particular way. Okay, so let's say we have a mobile app and it allows users to take photos and share them. Okay, so a user might take a photo and then want to see if it have uh, an upload feature with filters, right? They might try taking a photo with some bad lighting, and then they may want to share with someone, but they don't have proper internet connection, right? Another example is for an online marketplace. Okay, and this allows you to buy and sell products. So you might want to just search for products using different names, right? You might test the checkout from a mobile application, a desktop application, or might cancel mid-transaction, right? So these kind of tests is what you might be faced in like an interview or presentation. So, you do your solution and you're presenting it to um, some managers or customers, and then someone will ask, well, could you do this? Could you do that? Things like that, right? Yeah. Right. And then there is random testing, which involves generating some random inputs, right, from a valid input domain. Okay, so you might use like a random number generator. You might put some symbols and characters and see how the software deals with it. Okay, so again, it's very simple and quick to execute. It might reveal some unexpected behavior. Okay, but again, it's not a full coverage test, and it's not very structured. So it might be well documented, and also might be difficult to reproduce. All right, so let's say we have a web application, and it allows users to register and log in. And you might just randomly generate some username and passwords and with some special characters and see how the web page deals with that, right? So could you put a 100 character password, or something like that, some extreme but random stuff. Okay, also this is a lot of game testing is like that. So you will have persons testing like a video game that has been developed, and then they will just try to stress test it by using simulating random button presses or movements and see how the game reacts. Okay, which is a huge industry because gaming is quite popular. Okay, and I think, yeah, so we have ad hoc testing. So informal and unstructured type of exploratory testing. Testers randomly and informally test the system. Right? The goal is to discover issues that might not be found by your scripting tests, right? Right. So you have a website and then you enter some strange characters in there to search. Right. You click on some links, see the navigation is broken, or you try to do things like do operations too quickly, etc. All right, so that is, I think that, yeah, that's it, right? So that's it for the test design techniques. Okay, today we just sort of finished up with the black box testing that we started last week. Okay, so what I want to do now is I just want to go through the assignment, right? So we have some more students in class. So as I was telling you students earlier, I put up assignment 1. Okay, and that is due next Friday. But let's just go through it real quickly, right? Because assignment 1 is based on that lecture on test design. Okay, so for your assignment, you are going to have, well, usual stuff, right? In terms of your title page. Okay, and you could type up the answers, make sure you put them, you number them properly so I know what the answers are. And let's see if you could get it in by next week, Friday, too, right? Okay, so the first question has to do with equivalence partitions and boundary values, right? So you have a function that applies discounts for children under 10 years, right? So they're going to get 50%, seniors 65 and older, and then all others get no discounts. So first you have to identify equivalence partitions for the problem, and then you have to select boundary values for the problem. Now, if you recall, we did this to the end. Yeah, this is like one of the last stuff we did last class. Okay, so right. So here is an example of equivalence partitioning, right? So remember when we did this, we will like this example is the user login page. And we said that the username must be between 6 and 15 characters and the password must be between 8 and 20. So let's look at the username first, right? So between 6 and 15 for the user. Yeah. So between 6 and 15, that is a valid username. Anything less than that is invalid, and anything greater that is invalid also. So for you all, it will be a similar table you can do, right? Just state the valid ranges and invalid ranges. But very important, I want you to put the partitions, right? So partition 1, 2, 3. If it has a fourth one, partition 4. Right? Similar, this year we're doing, look at the credit card number. So the credit card number would only be valid if it was 16 digits, right? So this has 4 partitions we looked at, right? So 16 digits is valid. Anything less than 16 is valid. Anything greater than 16 is invalid. Okay, also, if you have no numbers, if you're not using numbers, it's invalid. And then you put in your partitions, right? So very similar for your question. Let's go back to that. Yeah, yeah, yeah. So very similar for your question. You will need to identify the equivalence partitions, all the partitions for this particular scenario. Okay. The other thing is boundary values, right? So right after we discussed this, we looked at boundary values. Okay, so boundary values, there are 5 different elements you identify, right? So there's usually a minimum and a maximum boundary value. In addition to that, you're looking at testing just one or just below the minimum value, just below the maximum value, and something out of range. Right? So out of ranges would be like above the value in most cases. Okay, so Did it have a short? Okay, so the file size one, right? We were looking at file sizes up to 10 megs, right? So that was like the maximum value. And then the range was from 1 to 10 megs. So 1 meg was the minimum value. So you would test with 1 under that, which is 0, the lower boundary 1, the upper boundary is 10, 1 just before that, which would be 9, and anything out of range, which should have been anything greater than 10. All right. So that is it for this question. All right. So everybody okay with this question? Well, at least based on what we talking about now.
For the most part, yes.
Right. Okay, yeah. I know you might have just go through the slides, right? Just to refresh, but once you just follow which slide to look at and where to look at it, I think you should be okay. All right, so that's the first question. Second one is you have a Python function, okay, and then you have to do branch coverage on the function. So let's see here. Just last week in the slides, we actually had some questions for you to try. Right, yeah. Yeah, so this question you all had, right? So a function to determine if a number is even or odd. And based on this piece of code, you had to do branch coverage. So very similar to the question you have to do for the homework, right? Where you have to fill a table with the test cases, right? But you're doing it in this format where you have the test case, input values, the branch, and the expected outcome. So in this branch, you have in this function, you have two branches. You have a true branch. So if n modulus 2 is 0, then this is the true branch. Else, this is the false branch, right? So what you're going to do is you are going to put input values to test both branches. So any number that when you do the mod of 2, you're going to get 0 you use. So like, for example, I use 4. So in this first test case, you've put an input value of 4. You're going to cover the true branch and the expected outcome. Now, the expected outcome is generally what is going to be returned. So in this case, you're going to return even. Okay, so it's going to return even, and then else is going to return odd. So to test the false branch, you're going to put a number that doesn't give you a mod of 0. So something like 5, 7, 9, etc. And then that's going to cover the false branch and it's going to give you an out. Well, the expected outcome is going to be odd. So remember, when you're doing answering these questions, this is like you are documenting the test case before you actually implement the test, right? So that's why it's the expected outcome. You're not testing it just yet. And that will be an example of how to do this question, branch question. Branch one, okay?
Yes, sir.
Yeah, okay. So the feedback again, yes. Okay. The question 3. So question 3, again, you have a Python function, but this time you are going to do some test cases to achieve condition coverage. So you have the template for the table. You're going to have the test case number. You're going to put some input values to test the conditions, right? Then you're going to put the value of each condition and expected outcome. So last week also there was a question in these slides that you all could have looked at. So we have here the function here that checks to see if a student is eligible for, let's just say, maybe a lower tuition course, right? So it's going to check student age and ID. If the student is greater than or older than 18 years or 18 years and they have an ID, they will be eligible. If not, they will be not eligible. So again, very similar to the assignment, you will have to design some test cases to achieve condition coverage. So the key here is you have two conditions and you need to design cases where you cover the different combinations of it. So it has to be condition 1 being true and 2 being true, then condition 1 being false, condition 2 being true, condition 1 being true, condition 2 being false, and then finally both conditions are false. All right, so that's going to have 4 test cases because it has to have all the combinations for different conditions. So what you're going to do is you're going to input values that ensure these conditions are what they are, right? So age equal to 20, that's over than 18, so it's true, and they have an ID. This is a Boolean sort of check, right? So it's either true or false. So they have the ID, and in that case, because it is if the student is greater than 18 years and has an ID, it's eligible, right? Other than that, if the condition 1 is false, so less than 18, but they have an ID, so that's false. True, it's not eligible. In this case, where they're older than 18, but they don't have an ID, right? So that is true, false, not eligible. And then when both conditions are false, right, you are going to get not eligible also. So very similar, you will apply this concept to this question, and then you complete the table. It's okay?
Yes.
Yeah? All right. Okay. That is the third question, right? And then the fourth question is we are going to try to achieve loop coverage, right? So there's a function here with a loop. There's a for loop. And you have to fill the table with, well, in this case, we're going to do just 3 different scenarios where you have an empty container, a container with 1 element, and a container with more than 1 element. Okay, and you have to list the number of loop iterations and the expected outcome. So let's go back to the question from last week. So I had something like that here. So this here is a function with a loop. Okay, so this function is sum numbers. So it's going to sum all the numbers in this container. So for n in the container, so for each element in the container, it's going to add that to total, whatever total is, right? And then at the end, it's going to return total. So this question asks you to do a loop coverage, and this is how you're going to do it. So same sort of setup, right? Empty container, container with 1 element, container with several elements. So you could put your 3 test cases. Here I put for the empty container, right? So empty container, how many times is the loop going to be iterated? 0. Why? Because it checks for an element in the container. If the container is empty, it has no element, right? So the loop is not going to be iterated any times, and it's going to return a total of what? Total was initialized 0 and was never changed, right? So that's how this expected outcome is 0. Now, the second case is using a container with 1 element. Now, if we use that, let's just say 3 is the element in it, the loop is going to be iterated 1 time, right? So it has 1 element, and then you add, so 3, and total is going to be whatever total was plus 3. So it's going to be 0 plus 3 is 3. And then the expected outcome is 3. And then finally, you want to have a container with more than 1 element, right? So I just randomly chose 3 numbers here, 4, 5, 6. In this case, the loop is going to be iterated 3 times, right? So you're going to have 4, 5, 6. So the first time, 4 is going to go in, right? So it's going to be 0 plus 4. Total now goes to 4, right? The second time, 5 is going to go in. The total is going to be 4 plus 5. That's now 9. So total is now updated to 9. And then the third time, 6 is going to be looked at. And the total is going to be 6 plus 9, which is 50, right? So when it prints total, it prints 50. Then you just fill out your table like this. Right, so expected outcome is 15. And that is it for that's what you have to do for the fourth question, right? But, just use the code that is here. So that's loop coverage. And then finally, you have a question, sort of an analysis question where you have to test a Python-based web application for an online learning platform, and it has some characteristics. So it must be able to handle sensitive user data. It has a large code base maintained by multiple developers and third-party libraries. And it also has multiple features, right? So user registration, login, video streaming, discussion forums, and payment processing. What you have to do is you have to take into consideration using white box and black box testing techniques. So that's what we discussed last class, and we sort of finished up today. And determine if, what is your analysis of or recommendation to use it? So what do you think are the advantages of using the white box over the black box techniques? And what do you think are limitations of using it? Okay, so you all can just do it. Right, so that's it there, 5 questions. Any?
It's a free answer question.
Yeah, for the last one, yeah, just a free answer question, right? So it's like, you do your analysis and you could talk about what do you think are advantages of using one over the other, and what are some limitations of it. All right. All right, good, thanks. All right. Any questions? Anybody? Everybody clear on the homework? Okay, anybody not clear on the homework? Right, so remember the homework, it's on Canvas, right? On Canvas. Try to complete it by next week. Next week, I'm going to be assigning, I'll assign another assignment. Yeah, assignment 2. Okay, if you all have any questions or doubts, let me know, and we could always talk about it, right? So important. Well, as I was showing you all, this course, it's a coursework based course, right? So there's no final exam. So I think in order to really keep on top of the course and to get out other courses you're doing, it's a good idea to try to finish the homework by the deadline dates, right? So you don't have any sort of overlap, and then it gets a bit frustrating and might get stressful, right? So try to finish as best as you can the homework by the deadline dates that's put up, right? And if you have any issues with that, again, you can let me know. Right. Okay, so now that is the end of test design. Now I want to go into Python testing. Right, so let's move on. Okay. So now we're going to start talking about how to write code using Python programming language to test Python programs, right? So let's go. So the first thing first concept we're going to look at is that of unit tests, right? So I'm sure you have come across this already, but a unit test or unit testing is to check a small portion of your program, so maybe like a function, right, to ensure it works properly. So you might have a huge application and you just want to test one portion, like you have a web application, you just want to check to ensure the login works properly, right? So it tests different pieces of code isolated to verify everything works well. So it's a little different from integration testing, of course, because integration testing, you put multiple functions in together or multiple modules, and then you test them as a sort of a bigger picture things, right? So unit tests are good because you want to be able to find any errors or bugs early. Because why? Because if it is you don't have your login working and then you launch your web page, or well, login might be an easy one because it's the first step. But let's just say you don't have something within updating a cart in an e-commerce website working properly, and you want to test end-to-end sort of scenarios. It might get a little tricky to test that to first isolate the error. Because when you're programming, one of the big things, especially when testing huge programs, is to sort of isolate where the error is. Right? So you want to be able to do that earlier. And by doing that, it's it's cheaper to fix when it is talking about money. right? So Python has a module built in called unit test, and we are going to use that to carry out unit testing effectively. All right, so what we're going to do is we are going to create variables, objects, and any data that our testing function will use. And then we're going to call that function, and you'd want to verify and store the results. So you're basically going to test to see the result of the unit test equals to something. And to do that, we're going to use what is called assert statements. So assert statements is going to be a big part of the remainder of the course. We're going to use it in the unit testing, well, the Python testing we're going to do today. And we're going to use it in the database testing and then the web testing. Right? So assert in itself is a huge, sort of, do I have it? I think I have it somewhere. Yeah, there are many assert functions. Okay, we're going to get to that. Right. So first of all, when you're testing your program, right? Or let's say program. When you're testing your program, ensure that your test code is in the same folder as the program. And that's just to make it sort of simple to execute. Otherwise, you're going to have to put in some paths and directories, which might get a little complex. So just ensure your test code is in the same folder or same directory of your program itself. And it is, and you should name the test file with test underscore and then the program code file name. So if you have a programming code name calculator, you're gonna name your test test file test underscore calculator. Okay, right. So we spoke about the assert statements, and the assert statement, as I mentioned, is a very important part of the Python testing, right? And basically, what happens is that it checks the output of the code with a value, right? So basically what the assert is going to do, this part here is going to check the output of the code with a value, right? And if it's equal, so if this is satisfied, then it has pass. If this is not satisfied, then it fails. Don't worry about that. We're going to see it in action quite a bit, right? Oh yeah, here it is. So this, these are assert methods. They have quite, a lot of different methods. We're not going to go through all of them, but just so that you have an idea, we're mostly going to use this one here, right? The assert equal. But there are many different methods you could use to test depending on the scenario testing, etc. And you, as I mentioned before, you'd find that with programming in general, it's quite a huge amount of libraries and different sort of options and features available. So you would only get into them when you start doing your development and you start researching, well, how do I implement this, or what's the best way to implement this? But part of the course is to really give you a good firm foundation so you could do that. All right, let's see what's next. Oh, okay, so we're gonna get into the programming now, right? Let me start up Spider. I should have done that too. Okay, I did. Okay, let me start up Spider. While it's starting up, any questions from anyone? Everybody okay?
I'm fine so far.
Yeah, all right. Okay, good. Let me see. Zachary, how you doing? Everything okay? Zachary probably stepped away.
Yes, sir, doing good.
Oh, it is? Okay, great, Zachary.
Yeah.
Okay, I just waiting for Spider to start up here, right? And then we will start it. So just let yeah. So just to let you know, the program codes, right? So the program codes that you are going to test will be given to you. So you don't need to write it or program it, right? What you're gonna have to do is for this course is you're gonna have to write the testing code. So the code to test the code. Yeah, so that's what we will do here. And it'll be the same thing with the database and the web. So for the web testing, you will be given like a website to test, right? And you will have to write the program code to test the website. Okay, Spider started. Okay, so this is Spider. Let me see here. Okay, let me share. Okay, so I'm going to share Spider. Okay, so this is Spider, and then I'm going to have to switch between two things, right? It's the presentation also. Okay. All right, so first let me start with the presentation. Should have done that. Okay, so presentation. So this is an example of a question, right? You are going to be provided with a code. So this code is called string operation.py, so a Python program. And then you have to design, first you have to design test cases for the function. So the code will have a function called toUpper, and you have to list test cases in a table. Then you have to write a Python test script. So this is what you have to write. You have to write the Python test script, or the Python script test underscore string underscore operation.py using the unit test framework. And then finally, you have to run the tests, and then you have to include a screenshot of the results. Okay, so let's see here. So this here is the, well, it's a very simple program, right? But this is the function, toUpper. Okay, so basically it's going to take any string that is input to this function and it's going to convert them all to uppercase. All right, so let me just write this up real quick here. Let me share. Where is Square here? Spider. So first of all, let me hold on. Let me just save this. One very important thing in Spider is that we have to ensure that you are in the correct directory, right? I'll show you how to switch the directories in a moment. Right, so this is going to be called what? String. It's going to be called. Right. Okay. All right, so this is Spider, right? And I'm going to write here the function. So the function was called toUpper, and it's taking a value of string. And then you're going to return s.upper. Right? Okay, so that is your function. Okay, the next thing you want to do is you are going to do your test cases. Right, so that's the first thing in the question. So the test cases for this, we just include two simple test cases. So we have an input of all lowercase, a string with all lowercase characters, and the expected output is to have them all in uppercase. And then if you have an input of a mixture of lowercase and uppercase, you're going to have an output of all uppercase, right? So now we are going to write the test function, right? Which is, what is it here, right? So part B is to write the Python script. Okay, so let me... Right, okay. Let me share back Spider, right? So now you are going to write that. So first you are going to save the file in the format test underscore string operation, right? So the name of the program file, test in front of it, and then you are going to write the code. Right, so this is how you will do that. Okay, so first you are going to import unit test. Right? You're going to import unit test into your Python program. Then you are going to import the program itself, right? So the program, the function from the program. So it's string operation. And now we're going to write the code for testing. So you're going to create a class. We just call it test string operation. And this is a general sort of format. So you all get familiar with this, right? This sort of casing, this sort of structure. So you're going to start creating a class, and now you're going to write functions to test the code itself, right? So the first function, we're going to call it test to upper, because the function was called to upper, right? And then self, we put self in there. You add self because it means this instance of the class will be updated. Okay, and I'm going to do self access, but cert equal, it's going to be string operation to upper, right? So the reason why you do so string operation here means you're referencing this file or this program code here, and then the dot to upper because you're going to use the to upper function within it, right? And then as the parameter, you're going to use hello. So remember, this was your first test case. And this is the thing here now. And the second parameter is going to be the expected result, which is all caps hello. And then we have the second test case. So again, string operation to upper. And what did we use? UTT underscore students. And the output should be all caps UTT underscore student. Right. So that's your test. That's your test. You're going to test the code with. And then finally, you're going to end it like this. Again, this is going to be straightforward, right? Name. So you're going to run it in the main, right? And this is going to unit test up. Right. So that here now is your, oh, I named this incorrectly. This should be test. So, I just need to rename this file. I named it, spell test incorrectly. E-E-S, right. Here it is. Good. Okay. Right. So this is your test file, the test underscore string underscore operation. And with this file, you are going to test the code here, which is just a simple function, changing everything to upper. Okay, so how do we run this now? Okay, so first thing is you need to ensure that your Python console is in the same location as your files, right? So mine is in location D SFEN3005. So I need to get to that location. So if I go CD here, right? So in D drive, and then I go SFEN3005. Right, so now I'm in the proper location. If you didn't change the directory, it would you get some errors, right? So now that we're there, now let's run the unit test. So to do that, you're going to do exclamation Python -m unit test underscore string the tab, right? And then press enter. Right, good. So this here means, so there's a couple things, right? This dot here, first of all, means only one test ran. And I just want to clarify that. It basically considers a function a test. So even though within this function, we're actually doing two scenarios, it is considered one test. And it ran that test successfully. And what that means is when it put the string hello into this function, the output was all capital hello, so it was equal, right? And then when it put the string utt underscore student into the function, the output was utt underscore student, all capital. So that's how they arrived to the tests passing. All right, so just going back to the question here. So the first thing is to do the test cases, and that's when you do the table like this. Second requirement is to write the Python script. And this is what I did, right? This script. And the third thing is to run the test and include a screenshot of the results. So I ran the test. So this is the command I use. So very important, ensure your terminal or console is in the working directory, right, of your project. And then when you run the results, you take a screenshot. Okay, let me do another example here so you have a look at it. And then I'll ask you if you are okay. Okay, so in this example, you're going to have be provided with some other code. So this is going to be called math functions.py. And then same sort of situation where you have to design test cases for the functions in that code. And then you have to write a Python script using unit tests and then take screenshots. So this is your function to test, right? So math on the functions, it has two functions in there. It has an add function and then it has a divide function. Okay, so in the add function, it returns the sum of the two numbers. But the divide function, it first checks if b is equal to 0, the second number is equal to 0. If it is, it raises this error, basically, right? This value error, and then there's a message. Division by 0 not allowed. If it is not 0, then it returns the outcome or the result of a divided by b. Okay, so first, let's look at the test, right? Test cases, because that's the first thing you have to do. So let's just say we do 4 test cases. So we do 2 for addition. We input 2 and 3. The expected result is going to be 5. And for the second addition test, let's say we put -1 and 1. The result should be 0. And for the divide, let's do first 10 and 2, where second number, or b, is not 0. You're going to get a value of 5. And let's test, right, that the second number is 0. You should get a value error, right? That's the expected output. Right, so now that we have that, let us now program that. So I'm going to switch back to Spider. Right, and let me first program math functions. So save as math functions.py. Then let me just type this up quick. So the first function is to add a, and where it's to add and it's taking 2 values, a and b, and it's going to return a plus b. And the second function is to divide a and b. And here we will first check if b is equal to 0. If it is, it's going to raise a value error. That's going to be division by 0 not allowed. Okay, if it is not 0, then it's going to return rn a divided by b. Okay. Okay, so that's the programming code you would get. And the next thing you need, well, what you need to do now is you need to write the unit test program, right? So first we're going to save the file. Same name as the code, and we're just going to put test in front of it, test underscore. And then we're going to write the function. So first we're going to import unit test, and then we will import math functions, right? Right. So this is we're going to look into this file basically, and we're going to be able to get the functions from there. So we will start off all the testing code by using this line. So class, you're going to pick a class, math, right? So the name of it would vary depending on what you're testing, something appropriate. Unit test dot test case. This would be same. Right? So you're going to start defining class. This is your class, and then you're going to define the functions in your class. So first, you're going to define a function to test the add function. Self, and then we're going to do the self assert equal math function dot add. And we had first 2 and 3, and the value would have been 5. Right, and then the second test we had was assert equal math functions dot add, and then we had what, -1 and 1, and that should give us 0. So that's the test the add function, right? So let's do some let's test now the divide function. So let's test divide self. And we're going to do self dot assert math function divide. And first we said we're going to use 2, 10, and 2, and that's going to give us a result of 5. And then we're going to do, so the next thing now is we want to test the situation when b is 0. Right now, because this is going to raise an error, we have to program it a little bit differently, right? So it's going to be like with self dot assert raises yes, and then value error. Right? I'll in the next slide, I think I'm going to let you all know about these different raises, right? So for now, let's just follow the code to test it. Right, so you have to put the with self.assert raises value error, and now you run the function, right? So FUNCTS.divide, and you're gonna have 10 and 0. Right, so this is basically saying when you have these two values, you put these two values into the function, you're gonna get a value error. Okay, so that's the two cases we're gonna run. So if name equals right, and let's test that. Okay, so let's run that. So you're gonna run it using the same sort of syntax: Python -m unit test underscore. Let's see, this runs right. So it says 2 tests ran. So 2 tests successfully ran. And remember I told you it considers a function a test, right? So this is one test, this is a second test. Okay, so even though within the function it had multiple tests. So you might be asking, well, if it fails, so let's just say we should have gotten, if we had a mistake error here and put this, what would you see? So you see you have some issues here, get some errors returned to you. Okay. Right. Okay. Okay, back to the slides, right? So right. So you would be, this is a question again, right? So you have to test math underscore functions, and you have to have test cases for the add and divide. You have to design test cases. So this is the first thing you're going to do. Put in some test cases to test the add and divide. Secondly, you're going to write the Python script test underscore math underscore functions using the unit test framework. Right, so this is the function I wrote. Okay, so this is what you will have to write, right? So when you this is the programming code that you have to write. And then finally, you run the test and include a screenshot of the results. So this is the function you're going to use. This is the command you're going to use to run the test. Again, remember the exclamation mark in front of the Python, right? And then you take a screenshot of the results. So this slide should be right. So I was telling you about the error handling, right? So these are the different errors that there are, okay? So these are different exceptions it has in Python that you could use and you may see. In the case for this example, we use the value error, but these are different stuff we could use, right? Right, so how those examples were? You all okay with it? Any major doubts or questions on it?
Aside from the actual terms and stuff to use within the code,
It's okay. Yeah. So we won't be getting too much into using any different errors and this sort of thing. It would be looking at a function and then using the function to create the test cases. Right? So let's look at another one real quick here. So this is a question using programming code cat.py. So it's basically it simulates a cart. So you're going to have add items. So it's going to take a container called cart and then an item. And the function will add the item to the cart and return the cart. And then this second function here is to return the total amount of items in the cart, right? So you're going to return the length of the cart, basically, right? So the length of the container. So same thing, what you need to do is you will have to design some test cases. First, then you're going to write your Python script to test the cart, right? And then finally take a screenshot of the results. So let's just first write the, let's write the cart function here. Let's save as cart.py. Right, so the cart function, what it does, program what it does, it has two functions, add underscore item, cart item. And here it adds the item, append cart, and then it returns cart. Right, and then the second function is total items cart, and then it returns the length of the cart. Right, so that's the program code we're going to look at. The next thing, or the first thing actually, is to do your test cases, right? So let's just say we have a cart and we're going to add an orange to it. So the expected outcome will be 1. And why is it, right? Because it will return that that cart and then the length of the cart. Okay. When you add item, you add another item to it. You're going to have 2 items in the output. For total items, if you do an empty cart, the expected outcome is 0. And then if it is you have an input of 1 item, the expected output is 1. And the reason for it is like this, right? I'll tell you why. Because the way how we're writing the functions here to test it is where we will, after adding an item to the cart, we're going to check the length of the cart to verify how much items there are in there. So after adding the orange, we are going to test the length of the cart to see if it has 1 item. Right? So that's why the expected output is 1. And if we have a cart with the orange and the apple, then we're going to have expected output of 2 because we're going to check the length of the cart. Okay, so let's just build that. Let's build that up here. All right, so we're gonna have, see, cart. So test underscore cart, right? And import unit test, import cart. Okay, and then class test cart unit test dot test piece. And then we're going to do, first we're going to test the R items. Right, so first let's have an empty cart. We just set up an empty cart, and then we are going to add one item to the cart. So cart dot add item. So the cart container is for my cart, and then the item is orange. ORANG. Okay, so how we're going to test this now? How are we going to test that there's an item in the cart, right? We're going to test it by checking the length of the cart. So it's going to be self.assert equal length of my cart. And then what's the length of it? 1. It means I have one item in it, right? So let's add another item to the cart. And we're going to add apple. Right, it's going to be self.assert equal length of my cart, and that should now be 2. So that's testing the add item function. So the add item function, it adds items to the cart, but we will verify that the cart was actually it has more items by checking the length of it. Okay. And now let's do the test the total items. So function to test total items. So, right. So you have find the cart, empty cart, and then we do self.assert equal cart dot total items. Right. So we're going to test this function. So if we check the number of items in this function, it should be 0. And now let's add something to the cart, right? So we're going to use the add item in this test scenario also, because we want to add something to the cart. My cart item banana. And then we're going to do self.equal cart total items, my cart, and this should now be equal to 1. Right, and say if right. So now let's test to see if these run successfully. So Python and unit test part. Right, so the 2 tests ran successfully. So in the first test, we had an empty cart and we added an orange. Right, so to test that the add item function did what it was supposed to do, which is add an item to the cart, we checked the length of the cart. So the length of the cart is now 1. We then added a second item to the cart, the apple. And again, to verify that the cart itself was updated, we checked the length of the cart, and it is now 2. So now that we want to test the total items. Again, we're going to start with an empty cart, and then we're going to check the total items in the cart is going to be 0 initially, and then we add 1 item in the cart, and then to check we check the total items function on that. In this case, it should be 1. Right? And right. So with that was the code, and then we ran the script, and this is the result. Right? It getting a little clearer as we do the examples. Another example.
For the most part.
Yeah, Gideon, is a little clearer.
Yes.
All right, good. All right, okay. So I have here another question on grade. Well, you're gonna similar sort of format. You're gonna be provided with the code grade.py, and you have to design some test cases, and then you have to do a Python script for it and then run the test. So basically the same thing we've been doing. But for this one, I want you all to try this on your own, right? So I'll leave the solution blank, right? So this here is the code, so you don't have to write the code. This is the code you're going to use, but you need to do the test cases and the Python script, and then you run it. Okay, so you all do that. Okay, good.
So can you just go back to Python about Spider? What the test
Spider. Yeah, Spider. Yeah. This one?
Yes, sir. I just wanted to get it
Okay, right. Yeah. All right, so let me just pause. Okay, so we're going to look at PyTest, and it is very similar to unit tests. And it checks a small part of the program, so it does unit tests, and it achieves basically the same result. You might find that PyTest is easier to program, right? Because you don't really program classes. Okay, and by doing that, you might find it a little simpler than unit tests. Now, one thing though is you have to install PyTest. Okay, so you will from your IPython console on Spider, you will install PyTest using this command here. So the exclamation mark pip install PyTest, and then you verify the installation with this command, right? So PyTest dash dash version. So very important, you need to install PyTest before you execute it. So when I installed it, this is how it looked, right? So yeah, so I installed PyTest, and then the version I had is 8.4.2. So you should get a similar version in. So remember to install PyTest before you try it. For the unit test, we didn't have to do that. Okay, so very similar again, like unit tests. The testing method is, you have to create variable and objects and functions, and then you will call the function and you will use assert statements as well. Okay, and again, the PyTest programming code should be in the same folder as your programming code you are testing. Generally, the PyTest will be named in a similar format, but you could include an indicator. So, for example, in the questions here, I normally end the PyTest programming code with an underscore PyTest, right? So it starts with test underscore string, well, the programming code, but it ends with underscore PyTest to sort of distinguish it from the unit test programming code. Okay, so let's go with the question, right? So you are provided with the string underscore operation.py. Okay, so we had this from the last time we ran this example, and then you have to design appropriate test cases. So you just reuse the examples that we had before. Now this is going to be different. Now we are going to write a Python script to test that function using PyTest functions. So here's where it's going to be a little bit different. So let me go back to my Python.
Pardon me, sir.
Hi.
What file is this on Canvas?
No, it is not on Canvas yet.
That's why. Okay.
Yeah, not yet, right? I'll try to put up this file this after class, right? And the recording might go up a little later because it's have to process, etc. Okay, so let us save it. So we're doing the string, but we're going to adjust the file name, right? You're just going to put PyTest, right? And you're just going to put PyTest at the end is to distinguish between the code using the PyTest functions and the code using the unit test functions, right? Okay, so let's write the PyTest code here. So to do this, right, you don't have to remember when we did the unit test, we had to import unit tests and these things, right? In this particular case, we are only going to just import the file that we are testing. So import string operation. And now we're just going to create functions to test those functions, right? So we're going to create a function test to upper, right? And you're going to use the assert statement like last time. String operation to upper. And the first test case was hello in all comma letters. And we're going to say that the result of this function is going to be all capital hello. And then we're going to do the other test, string operation to upper, and we said UTT, UTT, right? And that's it. So you see it much simpler in terms of coding. So this is what we did last time, a lot more lines of code here. And in this case, we're just going to do these 2 lines of code, right? So you write your PyTest function and then you execute it. And the syntax for executing PyTest code is a bit different. Okay, so it's exclamation PyTest and then the test code. Right? And this should give us, right, so the output is a little bit different, but what it's saying is it gives you some information about the environment and then the file that the PyTest file that it run, and then it gives you, where it passed, so that gives you some statistics here. Again, it has 1 dot, 1 test, even though we had multiple times we ran the function here. Well, we ran the string operation function. It was in 1 test to upper function in the test code, right? So that is how you do PyTest. And with PyTest, we have a verbose option, right? With the -v, where it gives you a little bit more deep information. And it actually tells you within your PyTest file, what is the name of the function that passed, right? So test to upper, which is this. So I find this is kind of helpful also. All right, so on this slide, right, so what you would notice is that the slides, I have all this information in. So I think when you all review the slides together with this recording, it should be, should be pretty good to get you all through it, right? Right, okay, so that was doing PyTest on the first file. Now we're going to do
Pardon me, sir. 1 second.
yeah, get it.
It didn't work for me. The PyTest didn't work for some
It
reason.
didn't work. Did you
Yeah.
install PyTest?
Pardon me.
This part, hold on, let me just step back. Yeah. Did you do this pip install PyTest in your environment?
No. I shall do that now.
Yeah, try that. Because unlike unit tests, we have to install PyTest before running these functions. Gideon, just let me know if you well, let me know how that turns out, right? Okay, so let's go to, yeah, so math functions. So same sort of question, right? You do the test cases and then you write your Python script to test it using PyTest functions, and then you run the test. So we will reuse the test cases from the when we ran it with the unit tests, right? So the same thing. And now let's run the PyTest functions. So let me switch back to Spider. Right, so we have Spider here, and I am going to create a new file and save it as math functions, but I'm going to include PyTest here, right? Okay, so we are going to say here, from functions import. So I'm actually doing this one a little bit different. I'm importing the functions from the file, right? But is going to give us the same result, right? So first we're going to set up a test for the adding of the numbers. So we're going to do the first one, we add two positive numbers. And then it's going to be assert add 2 that gives us 5. Then we're going to do another test, and we're going to add a negative and a positive number. So let's say mixed numbers. Assert add -1 and 1, and that should give us 0. Right, so that was the addition function. Now let's check the divide function. So test divide numbers. And we are going to assert divide. Right, so the assert means in this case, we're going to be calling the function divide from the math functions file. And we're going to use 10 and 2, and that should give us a value of 5. And then finally, remember we had one where we had the second number 0. So you're going to do test by 0. Right, and here, because it has a value error, this is how we're going to freeze it, right? So by test dot, this is value error. Right, so this is just specific to this situation where we actually have an error. Division by 0 about. Right, and what causes that? When we divide 10 by 0. Right, just to go back to this, remember in the file itself, the program we're testing, it has this value error. And so that's why we have this here. All right, good. So now that we have these tests, we're going to run it. But let me ask you a question. When we run this, how many tests should we see passed if all of them pass? Anybody? Anybody want to try it?
3?
3. If all these tests pass, right? So remember, it considers each function as a test. So in this case, we have 4 tests. So the first one, we're going to test these two positive numbers. This is the second test. This is the third test, and the fourth test. Okay, as opposed to this one where we only had 1 test. So you see here, when we run it, we're going to get the 4 dots, each dot indicating one of the tests. And if we use the -v option, it will go in detail, letting you know the status of each of the tests, right? So the tests add positive numbers, add mixed numbers, divide numbers, and divide by 0. Okay, and you're going to get each one of them pass. So remember, what this means here is when you run the add function in this file with the numbers 2 and 3, you're going to get a value of 5. So this is checking to see if when you run this function, it equals 5. When you run the add function with -1 and 1, you're going to get 0. When you run the divide function with 10 and 2, you're going to get 5, and you will, right? So divide 10 and 2 for A and B. B is not equal to 0, so it's going to return A divided by B, which is 10 divided by 2. And when we run the divide function with 10 and 0, it's going to raise the value error, right? So B is 0 is going to raise the value error. So you're basically listing you programming in the expected outcome. And when you run the PyTest code, it just verifies that the code itself gives you the expected outcome. Right, so where are we? Okay, you're here. Good. Right, so on the slides here, we have, right, so this is the function. It's on the slides. So you all don't necessarily need to copy it from the screen. You could paste it from the slides, right? Or type it over from the slides if you all want. Right, okay, so this is the command to run the PyTest code. And then you have the results, and then the results using the -p option, more details. Okay, so the third file we were using was the cart.py, so we're going to run PyTest on that one. All right, first thing, we will use the test cases. So we use the same test cases from when we did a unit test. And then we will write the PyTest code. So let's write the PyTest code for that. Spider. Right. Right. And then yeah, this save as test cart underscore PyTest. Right. And let's write the code, right? So port PyTest and port cart. So first let's test adding an item to the cart. Okay, so remember first we initialize the cart container, then we added an item to the cart using the function cart.addItem. We go for the container, my cart, and the item we said we're going to add an orange. Then to test that the cart actually has something in it now, we're going to check the length of the cart. So we're going to do assert length of my cart, and that should be equals to how much? 1, right? Because we have one item in the cart. So let's add another item to the cart. So cart.addItem. Now we're going to use the same container, my cart, and now we're going to add an apple to the cart. And how are we going to check to see if the cart was updated? We're going to check how many items are in the cart. I'm in the cart now, and it should be 2. Right? So that's testing the add item. So that's testing this function here within the program code, right? So let's go and let's test the total items now. Okay, so now we go find a function, test total items. Right, so set up the cart. It's empty. Just enter the grocery. Right, cart.total items. So how many items in the cart if you just had it? If you just pick it up basically. None. There are no items in the cart. So now we're going to add an item to the cart. So we have our cart, and we're going to add a banana. Right. And then we're going to check the cart of total items, my cart. And now it should be equal to 1. Right? Good. So that's your PyTest function. And next we run it. So PyTest, test cart, py. Right. So you see 2 tests pass, right? Because we have 2 functions here within the code itself. Even though we did multiple tests within each function, the program considers 2 tests. And we could do the reverse option, and we get what happens there. So if you notice, they considered like in the last okay, so this one, this test PyTest file had 2 tests. So when the first test passed, 50% of the tests in that file passed, and then when the both tests passed, 100, right? So previously we had 4 tests, so each one was worth 25% of the overall file. Okay.
So
Yeah.
essentially the PyTest just takes out the need to have to put in the self stuff and the if name at the end of it from
Yeah,
unit test.
basically the class, yeah. So you'd have to
Okay.
create the extra class like the unit test.
Okay. And
Yeah.
I got the I got it to work. I got
You
the
got it.
PyTest.
Oh, perfect. Great. Yeah, yeah. So just a reminder for everybody, before you run the PyTest code, you will need to install PyTest. But it is in the slides also, right? So you'll see the command there. Okay, so again, you have the code here, so you could test it. and then you can run it, and then this is what your results should look like. Right? Now remember when we did the unit test, I gave you all a question to try by yourself. So I just have the PyTest version to it, right? So you all could do this later. All right, so the last thing I want to look at is PyTest coverage. Now, what PyTest coverage does, it reports on the lines of code that were tested when the test was executed, right? And this could be used to help identify if any lines of code were untested during your PyTest, right? So we're using PyTest for this. So again, just like PyTest, you need to install the coverage. So the pip install coverage you will do. And then you could verify installation by doing pip show coverage. And this is how it looked when I installed it. So it should look similar to this for you when you try it, right? So let's just do the coverage stuff, right? So how we do that, first, before you do a coverage test, you have to write your PyTest program, okay? So the coverage uses the PyTest. So we did the PyTest already for the 3 scenarios, right? And then when you run the when you have the PyTest code, you get coverage by executing this command, right? Coverage run -m PyTest and then the PyTest file name. So let's do an example of that, right? So remember for all the 3 questions we look at, which are the string operation, the math function, and the cat, we already wrote the PyTest code, right? So now let's just check the coverage of it. So to do that, you will just run this command. Well, this is just repeating the PyTest code here we already have. So we're going to run this command. So let me just switch screens here. Okay, so we are going to run coverage run -m PyTest test string PyTest, right? So when the coverage runs, it looks like this, right? It really doesn't give you much information there, but to see the output, so the coverage report, you have to run this command, coverge report -m. And here, this is what gives you the information you're looking for, right? So it tells you that this PyTest code, when it ran, 2 statements from the string operation that py file was covered, and 4 statements from the test string operation that py file was covered. If we go back to the string operation file, how many lines of code in this file? 2, right? So you covered all the lines of code in this file. And if we go to the PyTest string operation, how many lines of code are in there? 4. 1, 2, 3, 4. Right? So basically you covered or you tested all the lines of code in the file, the code file. Now, this example is, it's pretty short and it's quite likely not going to represent what you're going to be faced with, right? But the principle is what is important. So let's run the PyTest on the math function now. Right? So for the PyTest coverage. So -g run -m PyTest test math. Right? So you have to run the coverage first, and then you will do the report. Coverage report -m. Now here we have some more stuff, right? So in the math function program and file, 6 statements were covered, right? So you see here it had 1, 2, 3, 4, 5, 6. And then in the test file, the Python test file, 11 statements were covered. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now let's just say we never tested the divide by 0. So let's just comment this off. right? We just comment so. And say we never tested that, we didn't bother to test that particular scenario where you had to test this part of the code here, right? And let's now run back the coverage and let's run the report. So you see what's going on here now? Right?
Last statements.
You see it, right? Everybody see what happened there?
Last statements.
Yeah, so less statements covered. They said one statement was missed. This one statement was missed. Which one is that? This one. Which statement? Line 6. This is line 6. So you see, this could be useful when you have like a code with a lot of lines, right? And you're testing, you can see which lines were missed. And then it's up to you. It's up to you at that point now to determine, well, okay, that was a very important line of code. I need to adjust my test file to incorporate it, or that's fine, I don't need to incorporate it. So it's up to you as the engineer to make that decision. But this is a powerful tool. I hope you all appreciate that. Okay, I think you just have to run it on the last one, right? So again, the presentation slide, it has, well, I don't have the example where I took off the line, but it's just to show you all, right? And then let's do the cat.py, right? So let's run coverage on cat.py. So go back to Spider, right? So we're going to run coverage, coverage, run dash m test cat. Right, so you run a coverage and then you look at your report. REG. See, cat.py had 5 lines of code. 1, 2, 3, 4, 5. And then the PyTest, it had 13 lines of code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, 13. Okay, so in this case, all the lines of code were covered. Right, so that's coverage. And I think that's, yeah. So again, in the slides, I have it, right? So I have cat.py and the coverage there. Right, and let's see, I think, no, actually, I think that might be good. And then finally, similar to the, we using the same grade.py code, you could practice by running the coverage on that file, right? And you could test it. Okay, any questions? All right, yeah, Gideon. No, it's okay. All right. Okay, so just a reminder for the recording when persons viewing it. Remember, you have assignment 1 up on campus. I give you all 1 week to do that, so you could. I would like for you to submit. It is due on Friday next week, right? Friday the 3rd. On Wednesday, the next time we have class, you will get your second assignment, and that will be based on what we do here today. So it'll be based on unit tests, coding, PyTest, and then coverage. All right.